Hello, I'm teacher Ivan from Wunna Educational Services. I welcome you to our second lesson. We are still looking at matrices. We have so far looked at 4 common terms that are used in matrices. The first one was element or entry, which meant the number in the matrix. Then the second one was the rows in a matrix, which are lines of numbers that go across the page. The other one was columns of a matrix, which meant the lines of numbers that go down the page. The fourth one has been the order of a matrix, which is simply stating the number of rows and columns in a given matrix. And we saw that the order of a matrix is determined by getting the number of rows times the number of columns in a given matrix. So we are picking up from there. Before we go to our fifth term, we need to do something concerning the rows and columns, or the order of a matrix. We are told that we have a point note. The number of rows is denoted by M, and the number of columns denoted by N. So when stating the order of a matrix, the number of rows is written first, followed by the number of columns, i.e. we write N, which shows the number of rows, times N, which shows the number of columns. So it is number of rows times number of columns to give us the order of a matrix. We go to our fifth term, that is leading diagonal or major diagonal. The leading diagonal or major diagonal is a line that runs diagonally from the top left hand corner to the bottom right hand corner of a matrix. This is what we mean. This is the top left hand corner running down to the right hand corner, and this is what we call the leading or major diagonal. Then we also have the minor diagonal. This is the line of numbers that runs diagonally from the bottom left hand corner to top right hand corner. This is a major, this is a minor. So those are the two diagonals of a given matrix. We have the major that runs from the top left hand to the bottom right hand. Then the minor that runs from the bottom left hand corner to the top right hand corner. And after looking at our terms used in a matrix, now let us look at the types of matrices. Type 1 is what we call the column matrix. A column matrix is simply that matrix with only one column. For instance, this has one column, but it has 3 rows. So this is what we call a column matrix because it has only one column. It can have as many rows as it can. Then we have a row matrix. It is also that matrix with only one row, but might have many columns. For instance, this is only one row, but has 3 columns. This is 1, 2, 3. Then type number 3 is the zero matrix. A zero matrix is that matrix with all its elements or entries as zeros. For instance, it has all its elements as zeros. It can have different orders. As long as all the elements are zeros, it is a zero matrix. Number 4 is what we call equal matrix. 2 or more matrices are said to be equal if and only if their corresponding elements are equal and are of the same order. For instance, if I'm to compare two matrices, I have two matrices here. I have matrix A, which is given by A, B, C, D, and matrix B, which is 3, negative 2, 0, 1. So if these matrices are equal, then it means that the corresponding elements of A are equal to the corresponding elements of B. And these two matrices have to be of the same order because they should have equal number of elements. This one has 4 elements, B has 4 elements. And now the corresponding, meaning we determine the position is A corresponds with the 3, meaning that if matrix A is equal to matrix B, then A is equal to 3, B is equal to negative 2, C is equal to 0, and D is equal to 1. That is what we call equal matrices. Then we go to type number 5, that is the square matrix. A square matrix is that matrix with equal number of rows and columns. We've seen how we determine the number of rows and columns, and therefore any matrix whose number of columns is equal to the number of rows is a square matrix. For instance, this one has 2 rows and 2 columns, so it is a 2 by 2 square matrix. This one has 3 rows and 3 columns, so it is a 3 by 3 square matrix. We also have the last type, that is an identity matrix. An identity matrix is a square matrix with 1 as an element in the leading or major diagonal and zeros elsewhere. It is sometimes known as a unity matrix, and it is denoted by capital I. For instance, this is what we call a 2 by 2 identity matrix. In its major diagonal, it has 1, 1, and it has zeros elsewhere. This is a 3 by 3 identity matrix. It has 1, 1, 1 in its leading diagonal and zeros elsewhere. So identity matrices are always square matrices whose elements in the leading diagonals are 1 and zeros elsewhere. So that will mark the end of our second lesson on matrices. Please, if it is interesting and if it is educative, why don't you share with friends? Like, comment, so that we may know how we are serving you. Otherwise, don't forget to hit the bell such that you get notified whenever we have a new video, so that we learn together as we enjoy together. I'm Teacher Ivan from Wuuna Educational Services. See you next time in our third lesson. Bye-bye.